Hey everybody, welcome back to the EKG review of the day. My name is Reed. Let's get going on this EKG. So first thing I'm going to do is I'm going to take a look and understand just what's going on with this EKG. I might look at lead 2. As I'm marching through, I see I've got a regularly occurring narrow complex QRS that's occurring at a rate, if I start here, 300, 150, 100 beats per minute. So we've got this narrow and regular. So these are a few aspects that I think help narrow down what we think this rhythm is. We've got a narrow complex QRS, so it's probably coming from the AV node for its conduction to the ventricles because it's taking that fast highway system that we call the His-Purkinje system. It's a regular rhythm. It's not something that is irregular that we might think of as associated with atrial fibrillation. And it's 100 beats per minute, so I wonder, is this coming from the sinus node or not? And so let's determine if it is. So I look for atrial activity, and what you'll notice here is you can pretty quickly figure out we've got atrial activity. If you look in between, we've got atrial activity, but I don't see any real organized P waves that are like sinus P waves. What I do notice though, if I zoom in on lead 2 down here at the bottom, what I am going to notice is that we've got this sawtooth pattern of atrial activity. And so that should kind of jump out to you. We see we've got sawtooth pattern. And if you scan throughout the other leads, you can see I don't see any good organized atrial activity here. V1 is a really good lead to take a look at these atrial sawtooth waves, and they are usually these spiky waves that you can see kind of throughout, and they're just imposing themselves. V2 has good ones, just spiky P waves. This is very common in what we know as to be atrial flutter, or typical atrial flutter in this case. And so these are good sawtooth flutter waves. And if you look at the rate of the flutter waves, they're roughly, the flutter waves occur at about 300 beats per minute. Right, the interval between these is about one big box, which would be 300. And that's common for atrial flutter. And we've determined that now we know that the atria is fluttering. Well, let's determine what are the ventricles doing. Well, we see that it's a narrow complex QRS. We see that each QRS occurs at about 100 beats per minute. So I can see that my ventricular rate is 100. So my ventricular rate is 100. My atrial rate is 300. So I can go ahead and just mathematically guess that this is going to be atrial flutter with 3 to 1 conduction, meaning that for every 3 P waves, I get 1 QRS. Right? Because if I do 300 divided by 100, which are our atrial and ventricular rates, I get a 3 to 1 ratio. And let's verify that. I'm really just going through this thought process for you guys to really understand what to look for with atrial flutter. And so what you'll see is we'll start with this flutter wave. We've got one flutter wave, another flutter wave, and then this flutter wave conducts to a QRS, and now we've got 1, 2, 3 with a QRS. So we've got a 3 to 1 conduction, right? We've got here, we've got flutter, 2, 3, QRS, 1, 2, 3, QRS, 1, 2, 3, QRS. And so that's the tricky thing about atrial flutter, is you might only see 2 or so flutter waves in between each QRS, but you have to remember that one of those is typically going to be buried. 1, 2, 3 with our QRS. 1, 2, 3 with our QRS. Notice that this last flutter wave is almost buried flutter wave. So, based on what we just counted, we can say this is confirmed atrial flutter with 3-to-1 conduction. Now, we're not done yet. We need to evaluate our QRS complexes because we know that the QRS, as it depolarizes through the ventricles, that has to do with what is going on from the AV node and below. Atrial flutter is what is going on with the AV node and above. And so if we look at our QRSs, we see that our QRSs are upright in lead 1. They're upright in AVF. So my axis is down and to the left, which is a normal QRS axis. We said our QRS is narrow, so that QRS is less than 120 milliseconds, which is reassuring. We've got good R wave transition as we see that R wave gets larger and larger. But as we go through, what I do find is I've got very large amplitude R's in the lateral leads, V5 and V6. If you zoom in on these, what I have found is if you look at this R wave, it starts from here, it ends all the way up there. That's a pretty significant R wave in V5. V6 is something similar. If I go to V6, we see this R wave starts here and it goes all the way up there where you can see it peaking. And so that might make me think, I wonder if this person has left ventricular hypertrophy, because remember the lateral leads capture that left ventricular depolarization. If we have a high amplitude, maybe we have some hypertrophy. And so I can take the R wave and say V6, and let's calculate the amplitude of the R wave. We've got roughly 5, 10, 15, 20, 25, maybe 27 millimeters of amplitude in the R wave of V6. And if I go to the S wave of V2, if I go to my S wave on this QRS, it's roughly yay deep. And I've got 5, 10, about 15 millimeters of amplitude in my S wave. And so if I add 15 plus 27 millimeters, I get 42 millimeters. And we know that the criteria for LVH is in V2 plus V6 is greater than 35 millimeters when you add those two leads together. So this does meet criteria for left ventricular hypertrophy. So that's why it's important to scan through those QRSs. No matter what, you think you've already got the rhythm down, well, we still need to look at the morphology of the rest of our EKG. And so, what is the final diagnosis for this rhythm? We've got atrial flutter with 3-to-1 conduction and left ventricular hypertrophy. So, I hope this helps. Have a great day.